All right, so we're going to talk about average rate of change and instantaneous rate of change. Now, you know, there's a lot of fancy words that are going to be thrown around today, but I want to make it very clear that when somebody says average rate of change, all they mean is the slope. All it means is you're going to do rise over run between those 2 points that they're telling you. What's the average rate of change from here to here? Well, it's the slope of the line. And then they're going to talk about what's called instantaneous rate of change. And we're going to get a way to do it right now. It's not going to be the final way that we are able to do it, but it is the way that we have now. It is a way that we need to practice for now. And eventually, once we realize what we're doing, we'll be able to make it easier. And we'll talk a lot about that in Unit 2. But for now, we're going to sort of stick with our limits and talk about all this stuff just in terms of limits. All right. So average rate of change. Again, all they're doing is they're telling you, find the slope between the 2 points that they're giving you. Don't overthink this. Don't turn this into something that it's not. It's saying, all right, when x is 6 and when x is 8, well, let's look. Let's find the 2 points. So if x is 6, then we plug it in. 12 times 6 cubed plus 12. And then we're going to do the same thing with x is 8 to get our y value out. 12 times 8 cubed plus 12. And it is totally okay for you to use a calculator for this. They're giving you ugly numbers that nobody wants to see, right? So I've got my calculator in the background, so I'm not like doing this in my head. I've just got my calculator in the background. 12 times 6 cubed plus 12. So here the y value is it's like 2604, yeah. So we've got the first point, we're thinking back like we're in Algebra 1. The first point is this one. Now we're going to do the exact same thing with the second point. We're going to do, instead of 6 cubed, it's just going to be 8 cubed instead. And here you crank it out in your calculator because ain't nobody got time for that. Y equals 6156. So here's our other point is 86156. So here's our 2 points. We're just going to find the slope between them. Rise over run, yeah? So we're going to do y2 minus y1. Just going to do it right here on the paper. Subtract. I got to carry. So here's our y value. And we're going to do the x value. And then, of course, I can simplify this fraction. The last numbers are 2. So this is even. So I can divide. Just going to be deliberately as obtuse as possible here. But you can use a calculator for this. No one's going to fault you. There's your slope. For this first one, the answer was for part A. So one thing to notice is like we're getting farther when we get farther away from 0 for this one, x is actually growing faster and faster and faster. So if we see the slope is this big number, 1,776, that's a big slope. At over that interval, your function is actually almost basically going straight up at that point, right? Not exactly straight up, but pretty close. So that's that first one. Let's do the second one just to get the practice on it. I'm going to scooch this up. We're going to do the second one now. Let's make it green. So once again, now here's our two x values for the second problem in this. It's just the same problem twice with two different numbers, right? So here we're going to say for this one, x is -1. And that's what's -1 cubed? It's just -1, right? So this is -12 plus 12 equals 0. That's our y value. And we're going to do the same thing with x equals +1. We're going to get one cubed is 1, so 12 plus 12 is 24, and that's our y value here. So once again, we're going to do the exact same thing. Rise over run. This one's much easier. It's not like some ugly 4-digit number that we have to work with. 24 minus 0. 1 minus -1. So here, the slope comes out to be 12. So it's literally just finding your x and y values for the 2 points that you're given. Here they're giving you the x value automatically, and then you have to find the y value. And they're talking about, oh yeah, it's over this range of intervals, it's over this, it's over that. Nobody cares. We're talking about, look at the two endpoints, find the coordinate for each endpoint. If the x value is 6, the y value is 2,604. If the x value is 8, the y value is 6,156, and then just do rise over run, just like you're in middle school again. Same thing with the second one. Yeah, they're giving you -1 and they're giving you 1, but just find the points and do rise over run. If you can break this down into like easy middle school stuff, suddenly, I mean, the words here that they're using are dumb and big, and you have to like think about what those words are, but don't overthink it. I promise you, if you overthink this, you're going to make it hard. And if you don't overthink it and you translate what they're trying to tell you, it's going to become so much easier. And I want to reiterate, average rate of change. If they say the words average rate of change is slope. Slope, and usually it's between 2 points like this. Like we did. So if you're asked to find the average rate of change, say to yourself, okay, what are the 2 points that I'm working with? What's the slope between those 2 points? Ta-da, you're done now. Don't overthink this. Let's do another one. It says, find the slope of the curve at the given point P and the equation of the tangent line at P. Okay. Now, Here's what's about to happen. Notice we only have 1 point, right? So before we had 2 points, now we've got 1 point. So we've gone from wanting to do average rate of change, the slope of the line between those 2 points, and what's called instantaneous rate of change. So all we're going to do, so we're going to have to think about what hopefully you saw in pre-calc. I'm knocking on wood here. Is what's called the difference quotient. Has anyone ever heard of the difference quotient? So the difference quotient basically looks exactly like the slope formula. It's just written in a weird way. Again, the f of something is your y. And these are your x values. This is just what was on the inside here is down here. What was on the inside here is down here. You can actually simplify this to look like this. And what this is showing is, hey, there's 2 different points. There's x, like here's your function. Kind of looks like that. Right? Well, here's x. There's the point that's h away from x going forward. And what we want to do is we want to find the slope between those. What's going to end up happening is, because we only have 1 point, we're going to treat it like we're doing the same point twice almost. So the way we do that is with a limit. So now I'm going to say the limit as h approaches 0. Basically, I'm saying, all right, I'm going to take these 2 points and get them closer and closer together. Now you're all connected. I don't want you all connected. I want to get out of the way. I'm taking this point and I'm moving closer and closer and closer and closer and closer and closer and closer until basically it's right on top of the other one. And when we're doing this, so basically we're getting the distance between the 2 points infinitely close, so that we can approximate what it looks like here. So this is what's going on. And we're going to do a bunch of these. So if you're looking at this like it's really freaky, don't. We're going to do like 1,000 of these. And like these are something that you're going to see over and over and over and over again. And by the time you've done like 2 of them, you're going to be like, oh, this is simple. Okay, whatever. So with this, the problem, as we've been talking about these past 2 weeks, is if there's 0 in the denominator and 0 in the numerator, we've got 0 over 0. We can't do that. So what we have to do is we have to play with our function until it works out. So let's actually put this in here. Here's our function, f of x. I'm going to make it look better, f of x instead of y. And we know that our function is this. We're going to plug in x plus h, where the x was, and we're just going to put the normal function here. So it'll look like this. -1 minus 9 times this minus, so right here, this is our f of x plus h, because I just took where x was, and I put an x plus h in its place. We're going to subtract the original function, just -1 minus 9x squared, all over h. I'm going to bring that limit along so I don't forget it. So now here's the thing. Every single time you do this and you simplify everything out, when you are done, the numerator will no longer have any terms without an h in them. All of the terms that have just a number or an x without an h are going to cancel out every single time. And you can verify that here. Look. So I'm going to just distribute this out, right? Do FOIL, right? And look what I get. I'm going to make sure that I stay writing all this all the time. -1 minus 9x squared minus 2 times, so 2 times 9 is 18, x h minus 9h squared, right? When you FOIL this out, you should get x squared plus 2xh plus h squared, and then you distribute that -9 into all three of those. And then this negative sign distributes into these, right? Minus and minus, we got +1 plus 9x squared all over h. And what I want to show you is that everything that's not an h term is going to cancel out. Look, -1, there's always going to be this +1 to cancel out with it. Goodbye. This -9x squared, there's always going to be a +9x squared to cancel out with it. Goodbye. Look at what we're left with. -18xh minus 9h squared over h. The limit of, as h goes to 0, of this thing. And now look, there's an h in each of these, right? There's an h up here, an h up here, and an h down here. I can divide everything out by h. And not all of them are going to be this hard. Not all of them are going to be this hard. Some of them are going to be like extra easy. But I'm going to go through and I'm going to show you the ones that are kind of difficult to navigate, because those are the ones that you need help with. I'm not, if you're going to have like the limit, the function is like 2x. That's not going to be hard to do. These ones are a little bit harder because there's more terms, but just be careful as you go. But now look, minus 9h. So here's the thing. Before, we couldn't just do this because we would get 0 over 0. There was a hole, right? We done got rid of the hole. So look, now I can plug in 0 and get my answer, right? Well, h is 0 now. Well, there's the 0. And if I look, I get -18x as the general slope, right? This is the slope, right? y2 minus y1 over x2 minus x1. This right here, this -18x, that's the slope anywhere on that function. It's not a constant slope. There's a variable in there, so depending on what x is, the slope changes, but that makes sense. So like, there's the slope of the curve. But now we want to find it at the given point P. So, okay, well, I found the slope everywhere. Now let's find what it is specifically here. And where is here? We're going to call this the general slope. Or, you can call it whatever you want. I'm just giving it a name so it has a name. So, okay, so when we're anywhere, negative 18x models the slope of this function, but x is negative 3, right? So at x equals negative 3, the slope is just we plug it in, right? Negative 18, we're going to plug in negative 3 for x to find out what our slope is. Negative 18 times negative 3, I think, is 54, right? So the slope is 54. So we found the general slope of the curve. We found it at our given point P. And now we're going to find the equation of the tangent line at P. Okay, so there's a lot more words there. What is a tangent line? A tangent line, I'll move you up. Boop. The tangent line is the line that has the same slope at that spot as the function at that spot. So normally we're going to see a tangent line. It's going to be the line that sort of skips right off the top of the curve at that spot. The slope of that tangent line is this. This is what we just found. This is the slope of the tangent line. I just spelled lime instead of line. Let's try line. Slope of the tangent line. That's what this is. Well, now all I've got to do is I got to make an equation, right? Because that's what they want. They want an equation. Now, I don't know what your Algebra 1 teacher, your Algebra 2 teacher, your pre-calc teacher talked to you about making the equation of a line. The equation of a line is just putting something down on the paper that models that thing. So what I'm going to tell you in this, the first of 15,000 times that you are going to do a problem that is kind of like this, with these directions, find the slope, plug in the number to find the slope at the point, make the equation. If your teacher at some point, and I can speak for 4 of you that I've taught you this, so the equation that you care about is point slope form. And I'm going to tell you, on the AP test, you plug in your x value of the point, your y value of the point, and your slope, and you just write it out like that, you are done. You are done, completely done. You have nothing more to do. You don't have to rewrite it in slope-intercept form. You don't have to rewrite it in bloody-blue form. It doesn't matter. If you're on the AP test, you put the equation in this gross form right here. Now you can walk away because you have done what they ask you to do. Don't do more than they ask you to do, ever, for any reason. If they tell you to do something, only do that. Find the slope of the curve. Okay, I found it. It's negative 18x. At the given point P, okay, I'm going to plug in the x value of P, and I got 54. And then the equation of the tangent line. All right, I've got my point, negative 3, negative 82. I got my slope. 54, right? Look, because we've got all the things that we need, right? M is 54. Our X value of our point is -3. Our Y value of our point is -82. Don't do more than you have to. Y minus Y1 equals M times X minus X1. You could even leave it as Y minus -82 equals 54 times the quantity X minus -3. You could do it, even leave it like that, but you know. So let's talk about a problem like this one more time. Thing number one, you have to determine what the slope of the curve is. At this moment, we only have one method. Chapter 2, you're going to learn the good method, taking a derivative. But right now, all we have is the limit as h goes to 0 of our difference quotient. Unfortunately, that's all we have. So we're gonna plug the functions in, simplify the top so that the whole gets canceled out, divide away all the extra h's that are there, and get our general slope once we take the limit finally. Then all we're going to do is we're going to take the x value of our point, we're going to plug it in and get our slope. And then we're going to take the x value of the point, the y value of the point, and the slope, and just put them into point slope form. And then we're done. I promise you, as we go forward, as we do more problems with new and different ways, this process is going to get easier. Right now, especially for, like I specifically put a tedious one here because I wanted you all to be able to work along with me as we did a hard one so that you understood the general idea. Like, we're going to do a bunch of these. So like here, same exact thing. Again, I want to model this one because it's like a 1 over thing, and we've got to simplify our fractions when we do this. So here's our function. So we're going to do exactly what I did before. I'm going to, you can even start here. I don't care. Just the first part is replace it with the x plus h minus the original all over h. Hey, and then put your limit out here. And draw straight, h goes to 0. And now we're just going to simplify the fraction, right? We're going to get a common denominator here. And I'll tell you, don't distribute anything in situations like this until you have to. Like, we're going to put an x down here, up here. We're going to put an x plus h down here, up here. And then we're going to rewrite it. So we got x minus this thing, minus x minus h, right? Over the x times x plus h part, all over h. And then when we do the rest of this, we can just write the limit. You can't forget to write the limit because I put an equal sign there. I have to make sure that I'm putting things that are the same. It's not equal to the fraction, it's equal to the limit of the fraction. So just be careful about that. Be better than me. Simplify your fractions here. X minus h, right? That will be just minus h up here, right? And then remember, if you've got a denominator and a numerator like this, you can always take this denominator and shove it down into the real denominator. So you can actually have x times x plus h times h. Well, now look, there's a factor of h up top. There's a factor of h down on bottom. And again, I'm not writing my limit. be better than me. And now look, I can just cancel out these factors of h here, right? They're canceled out now. I'm left with a -1 on top. And that's why I keep saying, you know, when in doubt, if you're not sure that you've written the same thing from step to step, put an arrow to say, hey, this thing I'm doing here, I'm implying this. So it's okay to do that. But make sure if you're putting equal signs, I'm trying to go on hard mode here. And now look, I can safely plug 0 in for h now, right? Isn't this just now x times x, which is x squared? -1 over x squared. That's the slope anywhere. This right here models the slope at any place on my graph. And now all I have to do is find, so this is the general slope. Now let's find the specific slope. Right, because x is 4, that's where we care about, right? We're just going to plug it in. -1 over 4 squared. And that's just -1/16. So this is the slope that we care about. That's our m. And now here's our x1 and our y1. And again, don't try and be fancy. Don't try and do anything special. Y minus y1 equals m times x minus x1. And then stop. Don't try and make it better somehow. This answer is correct. It's a final answer. It is an equation. It represents the tangent line that they want. Why would you do more than that? Don't do more than that. So once again, first, make your equation with your difference quotient. Second, simplify the difference quotient so the whole cancels out. Third, plug in 0 for h, now that it's safe to. That's your general slope. Then plug in the x value so you get your specific slope. And then plug in m, x1, y1, you get your tangent line. Easy. So again, what we need to do is we need to put the x plus h1 first. And we put the h on the bottom. And we did one like this before. We got to rationalize the numerator and get stuff down to the denominator. And I know that's kind of weird because we're normally used to being told to rationalize the denominator, but we need to get that h out of there so we can make it cancel. So I'm going to multiply by x plus h plus, like that, on top and on bottom. And again, don't like distribute this in. You don't need to. Just leave it alone. Remember, when you multiply a difference of a difference of squares thing like this, where this is the minus, this is the plus, but it's the same otherwise, it's just first term squared minus second term squared. So first term squared, x plus h minus second term squared. And just like I said before, you should expect all the non-h terms up here to go away. That's the point of all of this. That's the point with every single one of these problems. And again, notice I'm not distributing this bottom part in. There's no reason to. I don't want to. We shouldn't. Don't make life hard for yourself, because it's extra work that you don't need to do. Once again, I'm coming down here. Let's continue. And I'm going to get x minus x. Well, those cancel out like we wanted them to, right? That's what we expected. And this whole shebang in here, I'm going to write it out because painful, and pain is weakness leaving the body, right? And then now look, you've got an h on top, an h on bottom. One is left over on top. 1 over radical x plus h, the limit of which plus x. And now, again, h isn't in a compromising position. We can just plug it in. And we end up with radical x and radical x, so like two of them, right? 2. Well, this is your general. Now we're going to plug in at x equals 4. We know that this is 1 over 2 times radical 4. Square root of 4 is 2, right? Everybody's good saying that. So this is 1 over 4. 1/4 is our slope. We found it. Here's our x1. Here's our y1. I'm going to just write them down here so that it's clear. I personally, myself, I would always rather just have everything down in the same place so that I know what I'm doing, so that I don't have to keep coming back up here, you know? Like, I know I need these things. Let me put them on my workbench. So now, again, we're going to use our point slope form. Y minus y1 equals m times x minus x1. So this is what we're doing today. This. You are either going to be trying to figure out the average rate of change. So you'll take 2 points, make sure you have your x value and your y value of each point. You're probably going to be given the x values. Take those points, plug everything in, get x comma y, and then do the slope like you did in Algebra 1 in middle school. And then if it's not going to be average rate of change, they'll probably almost certainly say average rate of change, or say the rate of change over an interval, or something where they'll specifically talk about the rate of change, or they'll talk about something being the average of something. But you know, that's what you should be expecting here. With the instantaneous rate of change, they'll only give you the 1 point, and for almost all of these, they should just be asking you something like, find the slope of the curve at the given point, and then make the equation of the tangent line at the point that they give you.